We'll wait for a couple of more minutes. Yes, Kaviraj, let's start.
I think you're on mute.
Kaviraj, you.
Hi, good evening, everyone. Thank you for joining today's session. Welcome to the session. And it gives me great pleasure to introduce Shivkumar Kalyanaraman, one of our illustrious alumnus, to this session. It's actually Dr. Shivkumar Kalyanaraman. He's actually the Chief Technology Officer, Energy and Mobility, Microsoft Cloud for Industry, responsible for strategy and execution and strategic engineering partnerships in clean energy and e-mobility. Prior to Microsoft, she was Executive General Manager of Growth Offerings at GE Power Conversion, responsible for new line of business development in e-mobility, commercial and industrial solar and digital AI innovations. Earlier, he was at IBM Research India and the Chief Scientist of IBM Research Australia. And before IBM, he was a tenured full professor at Renewable Polytechnic in Troy, New York, USA. And she has degrees from IIT Madras in computer science, BTech, Ohio State University, where he did his MS and PhD, and RPI, where he did executive MBA. Shiv is a distinguished alumnus of IIT Madras, distinguished alumnus of Ohio State University, USA, fellow of the IEEE 2010, and fellow of the Indian National Academy of Engineering in 2015, ACM Distinguished Scientist 2010, MIT Technology Review TR 100 Young Innovator in 1999. Shiv is also a professional violinist. And in fact, I remember like looking at all the websites that he used to maintain on the internet. He actually perhaps has the largest repository of Carnatic music classes on YouTube and Spotify. And for the IIT people, actually, he was also ranked 3 in JEE. So, I was like really, in awe of him when I was first speaking with him. And over to you, Shivkumar. We are all excited to have you here, and we look forward to, listening to all those great insights that you are going to talk about. We will get started.
Yeah, thanks. Thanks a lot for your generous introduction, Kaviraj. Not everything is fully true, but okay, let me just
humble. Yeah.
Okay, so let me, can you see my screen here? I hope my screen is
Yes,
good.
yes, it is perfect.
Okay, yeah, so I will spend a few minutes introducing you all to, clean energy innovation and how, like, somebody from computer science can actually make a difference in, areas like energy, clean energy, and electric mobility, and those sorts of areas, and how you can do a lot of interesting, innovative work, as well as demonstrate leadership. There's a lot of opportunity both in India as well as globally. In the space, right? So just wanted to give you a glimpse of some of the opportunities. First of all, climate change is one of the biggest and hardest challenges that the world has ever faced. And it's going to be a multi-decadal transition that we have to deal with, right? Because of, trying to manage carbon emissions, which are entrenched across various sectors: energy sector, transportation sector, and industrial sector, and of course, agricultural sector, and so on and so forth, right? And in highly distributed, decentralized applications, there's been a lot of investments already made, and so on and so forth, right? So this transition is non-trivial at the same, so it involves a combination of technology development, it involves combination of deployment, interdisciplinary work across sectors, across disciplines, and so on and so forth, right? But the impact is also important, and I'm happy to say that my children feel that I'm doing something useful. So from a climate change point of view, it's fundamentally driven by greenhouse gas emissions. And if you look at the graph on the left, the 2 degrees centigrade greenhouse gas emission goal that was set in the Paris Accord COP meeting requires a significant change in the trajectory versus the blue line, which is a business as usual line, right? This involves ultimately getting the emissions down to zero, or what is called net zero greenhouse gas emissions across the world. And for that, you need to make sure you get to net zero across individual countries. Like India has a net zero by 2070 target. Different countries like US and others have 2050 targets, and so on and so forth, right? So this bending of the GHG, or a greenhouse gas emission trend, is non-trivial, right? It involves changes across multiple sectors. If you look on the right, where are these GHG emissions coming from? It turns out that a lot of the GHG emissions come from 2 major areas: energy and agriculture, right? And of course, there's other areas like industry and so on. And energy, when we say energy, it means fossil fuels burnt in the context of transportation, or in the context of supplying energy for buildings, for industrial use, and so on and so forth, right? There are many, many small slices, subsectors like aviation, shipping, and so on, so areas like iron and steel, and so on, right? Some of these are very difficult, some of these are relatively easier. There are technologies and so on and so forth, right? And there are many areas or slices of this problem. But one major pathway, a major trend that is happening, which is accounting for a large fraction of these changes, involves 2 major steps, right? One step is convert from fossil fuel to electricity in terms of the use of energy. This is called the electrification of energy. So for example, if you change from a scooter that is using petrol to buying the Ather or Ola scooter, that's an example of going electric in terms of transportation. Similarly, buying an electric car, right? Or converting from a heating system to an electric heating system. For example, your air conditioner is already electric, but in many other countries like Europe and US, the heating is actually done through natural gas, or burning propane and things of that sort. Similarly, in industry, you use for very high temperature applications, a lot of fossil fuels are burnt, right? So this is called the electrification of energy. The second thing is, once you have electrified energy, it happens to be that electrification of energy is also much more efficient than the alternative, which is combustion. Once you do that, you want to decarbonize the source or generation of that energy. In other words, you want to replace a coal-fired power plant or a natural gas power plant with a renewable power plant, like a hydro or a nuclear or a solar or wind, and so on and so forth, right? And you want to get high degrees of penetration on the supply side of these decarbonized zero carbon sources, right? So electrify energy, and from combustion to electrification, and then change the supply to decarbonization. So this is a major pathway. Of course, there are many other smaller pathways that are there. And one of the reasons this is a very exciting area is because some of the component technologies which have been developing for decades, right, like solar, wind, batteries, and so on, have hit critical mass. They are growing rapidly right now, as well as their costs have come to a point where they can be deployed with lesser and lesser subsidies, right, or actually no subsidies in many cases. So of course, there can be policy support for it, but that is going to drive natural adoption, a consumer revolution, or a B2B or an industrial revolution in many areas, right? So this is one of the areas. So this is a growth industry. So there's a huge transition and a huge growth that is happening across the world, across each of these sectors. And this is driven by significant cost declines in each of these component technologies, whether you look at it as solar or wind or battery or many other clean tech components are becoming cheaper and cheaper, and they'll continue to become cheaper and cheaper, right? And just like a Moore's law, this is driven by learning curves, it is driven by experience curves, and also better improved supply chains, more efficient supply chains, things like that, right? And of course, innovations in that whole process. But one message I want to share with you is that cheaper hardware is not enough, right? Just like various other sectors, you're going to have new problems that are arising, so where you have to become more than cheaper, and you have to become smarter. And the reason for this is that some of the two major areas of renewables like solar and wind are very volatile or highly variable. Okay, the solar will produce when the sun shines, the wind energy will produce when the wind blows, right? And these are quite volatile, and it's a function of the weather, right? Weather conditions across the world. So this is okay if when solar and wind were a small fraction of capacity of the grid, right? Oops. If you look at the right-hand diagram here, when you had a small fraction or under 10% of penetration of the total demand, this is okay because the volatility was absorbed by other, sort of sources of supply called balancing resources. But once solar and wind become more than 20, 30% of the grid, then this becomes a serious problem because there's no other, the others cannot absorb. Their economics are affected because of absorption of this, volatility. And ultimately, these resources have to start taking responsibility for it. They have to become smarter. And another way to look at it is they will only get paid, or their electrons will only get absorbed into the grid if these problems are sorted out. Okay, and another way to look at it is that the very penetration of renewables or the decarbonization will hit a fundamental constraint if you don't fix these problems, right? So this it turns out to be a lot more of a software problem and an AI problem and a cloud problem, which is why Microsoft is interested in this, right? It involves understanding demand, understanding supply, and continuously matching demand and supply fairly granularly across the world. So if you look at areas like electric mobility, these are also being driven by many of similar factors, government policies, new technology platforms, disruptive entrants, and a lot of investments in the automotive OEM space, right? This area is growing rapidly, as well as fleets are emerging that are absorbing a large number of vehicles. Consumers are starting to be willing to pay more to get more. They understand that it's a very different dynamic. If you buy an electric scooter, you'll have higher upfront costs, but then its operations costs are lower. You have energy security issues that are on display because all the geopolitics that are going on. India imports a lot of oil and gas, which is a huge part of its current account deficit and so on, right? So as you have more and more miles traveled that are electrified, it also has public health benefits because you have lesser pollution, your cities are cleaner, safer, and so on and so forth, right? It's a virtuous cycle that happens, and that's expected to drive growth. So in different markets, we are starting to see even fleets such as the Uber fleets or Ola fleets, and the commercial fleets for sort of delivery of e-commerce or other, whether in India or other markets, right? Different form factors are being deployed, right? And this starts to happen, and it will accelerate when the cost parity, right? When you take the total fixed cost and variable cost and you amortize it out, if that is better, that is lower than the benefits, then this will start taking a natural life of its own. And that crossover has already happened. Its crossover has happened in 2019, but the vehicles are still not yet available at mass and so on and so forth, right? So as we see over the next several years, you're going to start seeing all these deployments get driven up, right? So there is a lot of math, and if you go to my LinkedIn page, I have a number of articles I've written on these topics, looking at the economics of this, right? But the economics tell a very clear story. The economics has already crossed over, and it's becoming cheaper and cheaper, whether it's solar, whether it's wind, whether it's batteries, whether it's some of these electric vehicles and so on. So we'll start seeing an explosion of these capabilities, right? Oops. Okay, and as we go forward, the next 5-10 years, we will start seeing this apply to other forms of mobility as well, including short haul electric aviation. There's a company called Lilium, which makes these beautiful looking jets, and Berkshire Hathaway, Warren Buffett's company, NetJets, has recently made a deal with them so that executives flying around can go point to point with these sort of electric jets and so on, right? So similarly, as battery energy density becomes, crosses some critical threshold, we will start seeing a lot more adoption of things like drones and, these sort of point-to-point electric. Think of it like an Uber or Ola, but across cities. This will sort of transform lifestyles to be, and more remote communities will start getting, will start developing a lot more, right? So this could transform lifestyles as well. Just like when you have a new ecosystem that develops, there is rather than having gas stations, you're going to have electric charging stations which have maybe on-site solar energy storage, and you have many of these sleek dispensers. So there's an example of a Tesla charging station in California. So we'll start seeing a lot more of these charging infrastructure that gets deployed, and interesting business models for operating this and so on, right? So the large amount of infrastructure investment and innovation has to happen along with these. Similarly, when you have these expensive assets that are out there, people are looking for different ways of making money with these assets, right? So they want to keep these assets always utilized. They want to make sure that it can be used across first life, second life, and so on, right? So for example, a battery in a bus, electric bus, after 10-year life or 12-year life, can then go and operate as a grid battery, providing, sort of trying to match demand and supply on the grid, and supporting greater penetration of renewables, for example, right? So there are many companies which are doing the second life battery things right now using the first generation batteries that came from early electric vehicles, but then this trend will start increasing, right? So then there is the circular economies companies, like the Tesla co-founder has formed a company called Redwood Materials, who are trying to recycle, sort of materials out of older batteries and so on, right? So the circular economy things are currently fairly small, and it will become a larger and larger portion, but the primary market will also continue developing rapidly. Okay, so there are many such things. If you go back to the fossil fuel industry itself, there is a transition fuel called natural gas, and India is slowly but surely adopting a lot more natural gas in our economy. But one of the big challenges in natural gas is upstream. There are emissions of methane, which is a much more potent greenhouse gas. So there's a lot of work to use a combination of satellite, aircraft, and other, sort of geospatial information, as well as local IoT sensors, to detect these leaks and plug these leaks, so that you don't have these sort of phantom emissions that actually cause global warming as we use these sort of transition fuels, right? So, these are also IT problems or information problems that involves a combination of all these technologies. Similarly, if you look at some of the other harder to transform technologies, there are many millions of homes across Europe and US which are currently using fossil fuel-based heating. When I lived in the US and I was in Australia, so we had natural gas-based heating systems that have to be completely redone, right? You have to decommission a natural gas heating system and then replace it with things like heat pumps. It turns out that heat pumps are far more efficient. And you can have different technologies for it, but it involves fairly large capital expense, and you have to go and do retrofits in essentially millions of homes, right? And same thing at a higher temperature, heat applications in industries are a bigger challenge as well, right? And many of the harder to electrify sectors involve either very high temperature requirements or other requirements where carbon itself is an input into the whole process, right? And so there are a lot of interesting projects. Microsoft is involved in a Northern Lights project where it involves carbon capture and sequestration. Elon Musk is looking at a project of using carbon capture and using it as rocket fuel, things like that. So there are a lot of very interesting applications of these things. And of course, there are direct air capture technologies as well. So in summary, this entire space is quite fascinating because the entire electric grid is a real-time supply chain. It sort of looks like the old telephone network, and just like the old telephone network transitioned to the internet, and I was part of this transition early on in the early 90s. We are seeing a similar transition called the Internet of Energy that is happening as the power grid, which is a real-time system, is transforming to an Internet of Energy, and a lot of decentralization, decarbonization is starting to happen, and digital technologies are playing a huge role in this. To really thrive and succeed in this area, you have to have a combination of a lot of interests in learning about many of these technologies, as well as being able to work across boundaries of these disciplines. Right. So with that, I'll hand over and happy to answer any questions. I should stop my sharing.
Thank you, Shiv. I think very insightful presentation about the state of the industry, and I'm sure that what better than to hear from the person who is actually, practicing it and actually taking decisions based on all these parameters, right? Just want to get off to, before we get on to the audience questions, maybe a few questions from our side about get it started. So, just wanted to actually, know a little bit more about your IIT days. I know that when you joined the campus with a, with a JE3 and all of that, and how was your, 4 years spent in the campus? Like, what were some of the high points and the low points, if there were any, of the campus life, 4 years of BTech?
Oh, without question, it's 4 of my best years in my life, right? If you rank order all the years of my life, and these 4 years would rank near the very, very top, right? So clearly, look, it was a formative, when you're coming of age, as well as forming new friends, and we form lifelong friendships, as well as, we come in with a lot of aspirations, and, some of them, of course, unrealistic aspirations, but, at the same time, you are brought down to earth by the smart people around you, and you tend to learn a lot. Of course, we had Mardi Gras those days, and so there's just the very fact that you're living in, one of my cousins used to tell me that, hey, Shivana is living in a forest, right? So it's sort of almost like a sort of separate lifestyle that we were all privy to, and of course, the wonderful sporting in Schroeder and other events, right? That we were all part of. It was just a fantastic time. And Taram's Chai. I mean, there's this endless set of experiences.
In fact, I was also looking at your career profile, and there were some changes that happened, right, from being a faculty to getting back to industry, and IBM and Microsoft and all of that. So, more curious to know what were some of the triggers of your career changes, and right, because I think all of us have faced this issue of either to stay with the same company for like 25, 30 years, or move after 5 years, 10 years, and stuff like that. So what are the triggers for yourself, and what is, in your view, if there is a right duration for a person to spend in any particular role or a stint or with company?
Look, I mean, there's not like a magic number, right? So if, typically it takes some time to make impact, right? In any role, it takes 3 to 5 years to really make a big impact in, both getting involved in organization and involved in, suppose you're part of a startup, you have a growth phase that you need to, in general, whatever choices you make, you need to commit to that for a few years, right? So in academia, it turned out that I spent about 10 years in academia. And then, for family reasons and others, we wanted to live in India as well as grow our kids up in India and so on. So, it was pretty much personal reasons at that time to come back. And that also happened to be a transition where I had to move from academia to industry or industrial research. I've never really done a lot of startup work, but I'm very familiar, and I have a lot of friends in the startup land. So that's a very different lifestyle choice. But, in general, anything you do, you want to give enough time to succeed. And the goal is not just to, jump from one job to another job. All of us are going to become, are going to be quite successful in our careers and things like that. And making money and all of that is going to be natural. So you have to look at what more you can actually achieve, right? You have to have a calling or a purpose for every activity, and to actually make an impact in any role, it does take a little bit of time, right? Now that time, you could be a magician and do it in 2 years, but typically it takes 3 to 5 years for any role. I've tended to stick around in places for a little bit longer, but it's certainly an individual choice.
No, I think one part of it, of course, you mentioned that it was also mostly due to personal reasons that you actually shifted to India, right? But in retrospect, when you look at it, did returning to India, did it actually affect your career path and career graph? And how do you actually also, and addendum to that question is also, how do you actually look at the opportunities in India now, like, right? I mean, for example, when I was also a graduating student in 95, 99, I think the maximum number of people actually went abroad for MS and PhD, right, in a batch of 340. Now, I think we see a lot of students actually staying back in India. It's a very positive trend. So, did returning to India affect your career path, and how do you actually look at the opportunities in India as of now?
No, look, I don't believe it did. Of course, you can certainly compare with specific batchmates. Like, for example, Sundar Pichai was in our batch and so on. So, there are people who made it really big, and you can always have those sort of comparisons. Of course, at least depending upon the specific time when you move back and so on, there might have been some small constraints, and these are part of the job roles everywhere. But look, I don't think it really affected. But in fact, you develop quite a unique profile of having been in academia, having been in industry, in research, as well as in taking business roles and so on. It is just an arc that you are comfortable with. I place a lot of premium on learning a lot, and so that really helped me through my journey. So yeah, I could probably have been a bigger executive sooner in some places, maybe in the US, but I was fundamentally in academia, right? So if you are in one career track and don't change from career to career, so maybe you could probably go a bit faster. But look, I think in India, we now have tremendous entrepreneurial opportunities, which were unheard of earlier. And, really, you just got to look at what's in front of you rather than looking at the rearview mirror, right? So I think IIT gives us such a great foundation, of the possibilities. So it's really what you want to achieve and how you want to achieve it, right? So as you mentioned earlier, I'm probably known a lot more than my career for my Carnatic music website, right? Which is just a completely social entrepreneurial effort, which probably is more useful.
And you have, of course, had the opportunity to see a lot of people across in all these companies, the best of companies globally, right? And you have a view of how the current generation is actually approaching various problems. So in your view, what are some of the key skill sets that our students here, there are many more Shivkumar, Kalyanaraman in this call, right? So what are the kind of key skill sets that they should focus on nurturing?
Look, I think, the natural things that come are, we all have ambitions. We want to all make an impact on the world. Never lose that sense of purpose and ambition. That's very important. We most of us are very, deeply motivated, right? And we want to direct that motivations and to be the best versions of ourselves, right? So I think that's probably the most core important thing. And in general, I would strongly urge to have a learning or a growth mindset, and being willing to learn from first principles any new thing that you want, right? So when I learn about this business of finance, I learn it from first principles. So I can equally talk about free cash flows or return on capital as I can talk about, solar technologies or, sort of deep learning and stuff like that, right? So it's just that I think we have the combination of technology and business skills that we can pick up, and then the right mix of what you want to pick up and the impact you want to create is all in your hands. And as I said, if you really want to move faster and you want to have a very strong optionality, you should go to a smaller company and do your thing. Or if you want to have a great academic impact, you should go to academia. So I've had the opportunity to try out a little bit of all of these. So I think it's just a slightly different mindset and for success in each of these areas. But being able to enjoy your life and your family and everything else, just having that sense of thankfulness of everything you've got, as well as learning and growth mindset, and trying to say within that, look ahead and not in the rearview mirror, and what impact you can make, right? I think that's the essence of it, right?
I think that's a very, very thought-provoking act. I'm going to reflect a lot on that. That's really great. And my last question from my side is actually, in terms of now there are several domains that's emerging and all of that, right? So how do you actually, in your view, what are some of those domains which are going to be very significant in the future? And in addition to that is also data science is now, the buzzword everywhere. And so how do you see the data science as a domain for our students to actually get in, and what is the future, and what are your thoughts on data science as a future career option, basically?
Yeah, look, I think, I don't want to paint data science as one of the component technologies, right? So I sometimes joke that it has low barriers. Computer science and data science, all of these have low barriers to entry, right? Anybody can pick up. It's much more harder for me to pick up civil engineering or learn about solar or learn mechanical engineering and so on, right? So I think for people who have graduated from another discipline, please know that your core discipline is your superpower, right? So that's, I can tell you that it was very hard for me to learn electrical engineering, very hard for me to learn about solar or microelectronics or other things. But I was forced to learn that for some of the opportunities that I had to go after. I spent a lot of time learning about palm oil or sugarcane and other things when I was doing some work in agriculture. So look, I think in general, you have your core and areas of depth. There's other disciplines, right? So whether it's data science, AI or whatever, right? Machine learning or cloud and IT, IoT, and all these technologies. Anything, each of these you can pick up, right? The end of the day, what is happening is that software is the most malleable resource, like our CEO Satya likes to tell. Data is increasingly available because of the low cost of instrumentation and the ability to control and have cyber physical systems. So because of this, you're starting to see a lot more of these cyber physical or adaptive systems starting to show up, right? And with which there are many, many ways in which you can redesign these systems and make them far more efficient in the future, right? So I think we sort of look at how do we help the industry move faster, right? Or if you want to solve a problem like climate change or take a slice of it and say, today solar is penetrating at some rate, right? How do I actually break down the barriers for it to keep going or penetrate faster, right? So if you take that view, there are some of the trends which are based on hardware, some of the trends which are based on software, some of which based on AI or data science or IoT. I think the trick is to stitch all these things together and have a clear view of how that impact gets made, right? So currently we are applying deep reinforcement learning, a lot of deep learning technologies and so on in the context of renewables, in the context of energy storage, in the context of new market trading, and at the same time the knowledge of finance and how those things change. Knowledge of how fossil fuel prices or other things are going to drive changes. These things inform us to have an impact, right? So there are many areas where, like I mentioned, all the way from electric aviation to literally rocket science to other areas in biotechnology and so on. Where so computer science in general and data science are becoming applied disciplines and permeating all these areas, right? So there's software eating the world or AI eating the world and so on and so forth. So which means that it's getting enmeshed in it. So it's a combination of a domain as well as knowing all of these technologies that are going to matter a lot, right? And there's what's so exciting about digitization is that you can actually transform many of these domains, and it involves learning a lot. I mean, I didn't know the first thing about solar, so I went to Coursera and picked up solar courses. Now I can talk intelligently about all these areas, right? So similarly, I didn't know anything about batteries, so I went and learned about battery technologies, right? So I think what we as IITians and so on have is the ability to learn and the confidence that we can learn. But we should not have overconfidence, but we should be able to learn that and then stitch these things together, right? I think that's what I would emphasize beyond any specific discipline.
Thank you for all these responses. Now I will hand it over to Nandana to coordinate the rest of the questions from the students and other audience present here. Nandana, over to you.
Good evening, sir. I have collected a few questions from students, so I'll ask.
Yes, Nandana.
So the very first question is, how much of this transition to green energy would depend on moving away from lithium to maybe completely graphene or other ion batteries?
See, okay, so the way to look at it is what is lithium-ion battery, right? Ultimately, it is providing a capability for you to time shift, electricity supply to meet electricity demand, right? You have to understand, again, from first principles, what are you trying to do, right? So when you have supply and demand that are mismatched and the grid is not able to match them, you're trying to provide some matching technologies. Either you can time shift this technology or you can space shift these electrons through transmission and distribution networks to meet them, okay? So these are the two fundamental areas. Now, lithium-ion is one specific battery technology that is actually dropping in cost rapidly, and it's highly modular. And it's also being leveraging the investments that are happening. as well as vehicle batteries, and therefore the cost declines are much faster, right? So therefore, it is likely to be one of the major, technologies for battery technology. But at the same time, if you reframe the question and say, hey, what is those flexibility resources that can help you match demand and supply? Okay, you can have alternative technologies like there are sodium ion and other chemical battery technologies, or you can have heat as a form of storage, right? So at a high temperature heat. For example, if you generate solar heat or heat from other applications, and then you can store it in some molten metal and those sorts of things, even in modular nuclear reactors and so on, which are coming up. So those can also provide rapid battery-like functions, right? Because at high temperature heat can be efficiently converted to energy, right? Which is the fundamental of how other fossil fuel plants work today. Similarly, you can have even data centers of the future, like cloud data centers. One of the projects we are working on along with Microsoft Research is a project called Virtual Battery, where you can take computation. And if you look at your computer, when you're running computation like AI training job or whatnot, right, you're actually using power, right? But computation can be quickly shut down, okay, or it can be quickly fired up. And when you quickly shut down or fire up, you can also turn on the computing, all right? Or you can run your computer faster or slower. By doing this, you can actually provide power elasticity. So you can then look at, if you have a set of servers, the whole thing can not only provide computational services, but it can also provide a battery-like service, right? So the right way to think about it is that you have flexibility services, and then you have embedded batteries that are already there in electric vehicles. As you have a lot more electric vehicles, if you do the simple math, a Tesla car has about 50 to 75 kilowatt hours. Okay, if you have 1 million cars, you immediately will have several tens of gigawatt hours of battery available in distributed locations, right? And as they are connected to the grid, if you can coordinate them, then they become essentially a battery that's available, even if you can only have one-way flows of electricity. So I think what is happening is that there is a wide variety of flexibility resources that are getting available, and lithium-ion is one of them. Of course, there are many other technologies, and for example, Reliance is investing in some new technologies that have very different profiles and so on. And of course, I know IIT is working on some aluminum air and other type of technologies. Each of them has its pros and cons. But fundamentally, you can look at all of these as forms of energy storage. And there is a abstract function that they're trying to provide. And the goal is, how do you achieve that function, and how do you lower the costs enough so that you can deploy them and then scale it up, right? I think these are the right questions. So it's not like either or, one is better than the other kind of stuff.
Okay, sir. So the next question is, with regard to the COP26 goals that have been set for the year 2070, why are we estimating these many years for achieving our goals when we clearly need an immediate action? Or how can we speed up the transition process while keeping it just and equitable for them?
Correct. That's an excellent question. But I think the simplest way to understand it is in a highly personalized way, right? Like, for example, I'm sure each of us has a two-wheeler, right? Or a four-wheeler right at home, like either a scooter and so on, right? Guess what it runs on, right? It runs on petrol, correct? And we already know that petrol costs are going up or diesel costs are going up. And we know that a lot of petrol gets imported and we have an energy security problem, correct? Everybody knows this, right? And it causes emissions, correct? So let me ask a counter question. Why don't we change immediately, right? Why don't I just get rid of my electric this and change it over to electric vehicles, right? Ask each of you, reflect on that question, right? Because you have already invested in your vehicle, right? So first thing is, you have invested in a vehicle, and sort of when you already have invested in something, you have a sunk cost and you have to transition to another vehicle. And what if I tell you that, hey, the Ola scooter or the Ather scooter, rather than being 50,000, is 1 lakh. Okay, so if it's a double the cost, but then it costs less to run, okay, it becomes confusing. Somebody has to do some basic math to say, oh, okay, maybe over a lifetime of 5 years, it becomes better, right? So if I tell you, hey, I have a new technology, with 5 years, it'll pay off, will you buy it? Okay, but so essentially now you have to transform, literally, India has 1 billion people, right? And let's say there is 500 million scooters out there. So you have to transform 500 million scooters. So it cannot happen overnight. Right. So, so I think it is a set of investment decisions each of us has to make. There's an economic decision. There can be subsidies. The government cannot possibly subsidize all of this, right? Yes, they can provide limited subsidies, but at the end of the day, it has to be a consumer revolution that is there. And even if you want to do it, the guys like Aether was a startup coming out of IIT Madras, right? They have to ramp up production, right? They can only ramp up so much, right? Even if I say I want to have 100 million or sort of 500 million scooters, they cannot have it overnight. So it takes a bit of time. Similarly, you have about 2 billion cars out there, right? If you want to actually just take the light vehicles, you want to transform that entire thing, right? Right now, the penetration of electric vehicles is about 3%. So there's a long headway to grow. And of course, the growth gets faster if the economics become cheaper. As your vehicles become cheaper, then people will naturally say, hey, I'm going to buy it, right? My next car is going to electric. So then over the next generation, it'll transition. Just like, we have these boomers like me, who are getting out, and then you guys, the young generation is coming in, right? So it takes some time to push out the old and get the new, right? So we are like fossil fuels. Okay. And, you're the renewables, right?
Okay, sir. So the next question is why solar energy can't replace fossil fuels so fast?
It's not either or. I think solar is one of the renewable technologies, and it's expected to be one of the most important renewables, right? And in fact, solar is dropping in costs 10 to 15% a year, okay, on average, right? It turns out that it has learning rates of about 25 to 30% for every doubling, and it tends to double every 2 years. So if you do the math, about 10 to 15% a year, it drops cost. Think of it like a Moore's law of reducing, in terms of reducing its cost, right? As the cost gets dropped, especially in large installations like a big solar farm that is connected to the utility and all of that, right? Those are happening. But, solar obviously has a basic problem, right? So the sun shines only during the day, right? And, in the monsoon season, the sun doesn't shine so much, right? So suppose you have all solar farms, let's say we completely transform India to solar. Okay, no more coal, all energy will come from solar. Okay, you have a problem, right? You will not get electricity in the night. Okay. Second is that when in the monsoon, you'll not get electricity. So you have a problem of this time shifting of thing. And then there is something called a correlation or a covariance effect, right? So when you have clouds all over, like you have a monsoon season, it's not going to produce, right? So, but interesting thing is in the monsoon season, it turns out that the wind energy produces a lot. And monsoon season, it rains a lot, right? Therefore, hydro tends to produce a lot. Okay, so there are these natural, what we call anti-correlations, or, like wind tends to be more when solar tends to be less, but it's not perfectly anti-correlated, right? So you can now have a portfolio effect. Okay, now if I take a portfolio of wind, solar, hydro, etc., then that actually creates a less volatile, just like you construct a portfolio of stocks and bonds and so on, you have a less volatile portfolio. But still you'll have residual portfolio, right? In India, we're all used to power cuts and so on, right? But most developed markets, they hate power cuts, they call it huge blackouts and stuff, right? But then you have to smooth the remaining out, and that's where storage comes in, right? Flexibility resources come in and so on. But this entire transition to all these new technologies, so it's a combination, it's solar and wind and storage, and maybe new forms of nuclear, modular nuclear, and other technologies that are out there, right? So, and of course hydro and more modular plants, right? So each of that has their own economic benefits and so on. But solar, ultimately all our energy comes from the sun. Okay, so in some sense, fossil fuels are sort of like a battery where you've taken the sun's energy in the past, inefficiently converted it, and you've stored it in fossil fuels, and then you inefficiently combust it and then use it as energy, right? But and then you have carbon emissions, which then store the heat, and therefore you have global warming, right? So so fundamentally, all the energy for us comes from the sun. Okay.
So the next
in some sense, all is solar. Yeah, go ahead.
So the next one is, as a beginner in data science and programming, if someone is interested to merge data science and clean energy in nearby future, what are the possible paths he can follow?
I would say the simplest thing is go and work in companies like Aether, which is a fantastic company that came out of IIT Madras. Go and work in Ola Electric. Go and work in, of course, I have a group in Microsoft also. But there are places which are applying these technologies. It is better to go and work. Let's say in Chennai, there's Ashok Leyland, which is rolling out electric buses, right? go and work there. See, they are desperate for people with data science backgrounds and who are willing to learn about electric batteries and things like that. You will learn a lot by applying it, right? So when you learn, there will always be a domain, right? So when I had to first learn about solar, or as I said, sugarcane, I didn't know the first thing about these, right? So I went and read books, I went to the internet, I went to YouTube and learned about this. So, by combining learning what are the fundamental problems, and then understanding, hey, if I have this data, what can I do with it? If I have, then once I have this data, how can I apply these algorithms? What are the limits of these algorithms? How quickly can I apply? What are the limits of what can I do? I think just that whole process of doing things you'll learn a lot, right? So I would say just go do stuff, right? Or if you're academically oriented, go work with professors who are rooted in these energy domain, right? And you guys in IIT Madras, you have you're working with Elon Musk and stuff like that on Hyperloop and all kinds of crazy stuff which I have no clue about. Okay, so I think just working on those sorts of things, you'll learn a lot, right?
So the next one is, does India have a full worked out plan or transition system to shift into a renewable energy based economy, keeping in mind the circularity, viability and environmental impact?
Yeah, I think one of the things I would say is nobody has a full worked out plan. Okay, it's not me, not India, not the world, and so on, right? So it's like this elephant which is so huge, and everybody is sort of feeling around and so on, and things are changing, right? So there is a direction, right? There's a policy, there's a goal, like there's a 2070 net zero goal, but there's no magic number about this 2070. Why can't it be 2060, right? So if you actually even pull forward, emissions reduction by 1 year, it can be a huge impact, right, on health and on society and future global warming and so on, right? In India and so on, it's future avoided emissions that are going to be key, right? So if we can do magic to lower the costs or enable deployment of technologies or enable adoption of electric vehicles faster than normal, and these are just few examples, but that can drive the adoption much faster. Yes, of course, there is sort of different angles of which is what is possible, but ultimately I would say having an engineering mindset and not taking anything for granted, right? So yes, while there are broad goals, it is up to engineers and innovators to actually drive things even faster than it's possible. Okay, why can't we do the same 2070 goals by 2050, right? 2040. I mean, there's nothing stopping us, right? So it's just that you ask questions from first principles and then push forward and make stuff to happen, right? So yeah, we need a lot more Elon Musks in India.
So the next one is, what are the different methods you keep educating yourselves and keep up to date?
Hey, see, when we were kids, we didn't have YouTube, or I keep joking with my kid, when I was studying for IIT, we didn't have YouTube or, online tuition and stuff like that, right? So, I think I would just say, hey, you guys have YouTube, we have the internet, man. So, when I want to learn about anything, I just go to, Google search or YouTube. You can find whatever you want over there, right? So all you need to know is to be able to ask questions, right? All you need to be able to organize your thoughts and start having the standard scientific method of be inquisitive, have curiosity, ask questions, and then pose the questions to Google, right? And then you'll get answers. And then, you can learn, just iterate fast on that. So I would say learning is just a process of scientific and just relentless, sort of question answering. And then, YouTube is more than enough for you to learn whatever you need to learn.
So the next question is, while moving from fossil fuels to battery technology, are we not creating another problem to how to safely dispose of these batteries after they reach the end of their life? So we should not be creating another environmental concern by solving one.
Yeah. I think there is a sort of misconception that quote unquote chemical batteries are somehow bad and so on and so forth. That's not necessarily true, right? Chemistry ultimately is a function of all the elements that are there. And like if you look at redwood materials or others, they're already in the process of starting to recycle and do those sorts of things. Yes, and there is an aspect of circular economy But if you just look at the math, right? So you're going to have a huge exponential growth in sort of batteries and solar and so forth. Ultimately, you will have a recycling industry that will develop that will be able to recycle, materials. So if you look at a solar panel, right, you have silicon, you have actually silver, you have copper. I mean, you can sort of recycle all of those kinds of things, right? And it's just a matter of being able to collect from distributed setups, have just like, see, if you can do garbage waste collection, why can't we do silicon collection, right? It's not a big deal, right? So it's just that today we might be sending our batteries to Belgium and Singapore to recycle. Why can't we build a recycling industry in India, right? So it's not a big deal, right? So it's just that somebody has to think from first principles, make that industry, if you can send to Belgium to recycle, you can definitely do the same thing in India, right? So it just requires first principles thinking and to set these things up, right? So these are all, I would say, any specific problem that has not been solved is an opportunity, right? It's a solvable problem. Unless it is constrained by the laws of physics, it's a solvable problem, right? So everything that you learned in JEE, the ability, think of it as a problem to crack. I mean, it's a big deal. You guys have cracked harder things, and there's all peanuts compared to that.
So the next one is, are companies showing the willingness to reduce their emissions at the cost of reducing their product, or will they have to be forced by regulations?
See, I think there is two things, right? See, what happens in general is that when society puts a cost on what are called externalities like carbon or pollutions and other things, and makes that cost apparent to companies respond to that, right? And then, of course, companies also have what is called a social license to operate. So if societies feel that, hey, to operate in these markets, or I can get more sales by having a different posture, they will tend to do it. Okay. Of course, there is always quote unquote greenwashing and all the negative stuff that can happen. And also, if you look at Greta Thunberg and all the things she's saying, right, you can move faster, right? And to move faster, it is actually a false equivalence to say that you actually have to reduce consumption, right? I think, just think about it, right? If solar energy or renewable energy can be made much more cheaper than regular energy, you can start to have a much more energy intensive economy. Okay, so you can have more units of energy compared to labor. Okay, you can have a lot more automation and robotics and industrial automation and other things that can happen. So you can, I foresee that once we have a lot more renewables, we will actually, initially there might be a reduction in aggregate energy consumption, but over time you'll have a rebound effect and you will actually use a lot more energy, renewable energy in the future. So I think the idea of reducing stuff, maybe it is true under certain circumstances and if you want to front load the emissions reductions, right? So but fundamentally, the right way to look at it from a supply side response in an economy is how do I reduce the cost of the component technologies, right? If I can reduce the cost, I can actually scale up, right? Solar, wind, all these technologies I showed you, the cost curves are coming down, right? Any incremental 1% improvement in reducing the cost and that curve tends to have a compounding effect, right? Which will drive up adoption, right? And so I think I think of this as the following, right? So focus on how we can either change the cost or provide new capabilities that can help drive up the adoption of these technologies and make these much more attractive and so on. Yeah, it may take a bit of a time. It is not that we need a government or a big brother to tell us and so on and so forth. But as a technological organization, there is a lot to be done in technology. Yes, policy and other things can help drive and focus the energies and so on in some area. But I think there's a lot of leeway which can be done just through cost. It's not a zero-sum game.
Okay, sir. So the next one is, what are the systems to decompose solar systems after a particular period?
When you say decompose, if you have a solar panel, right, you have an aluminum casing, you have sort of silver and copper, and then you have the underlying silicon, right? So what will happen is that if you can just remove the copper wiring and the silver wiring, the rest of the silicon you just remelt. Rather, if you look at things, today you have silicon that goes into ingots and then get pure silicon, and then you come up with polysilicon. Then this goes into that recycling thing. It's not fundamentally a very hard problem. You have discrete components, and increasingly they're being designed in a way that it is recyclable in the future much more easily, right? So it's actually overblown. These problems are fairly straightforward.
Okay, sir. So the last question is, can you please discuss some of the projects that your group at Microsoft is working on, if possible?
Yeah, so as I mentioned, we are interested in seeing how we can drive up the rate of clean energy adoption and electric mobility adoption. So that's one of the areas we're driving. And our hypothesis, like I showed in my slides, is that renewables, as they penetrate, just because of lower costs, they will start self-limiting, because they will add a lot of, electricity in the grid when it's not needed, or excess volatility or excess supply. So you need to better balance demand and supply. So this is a fundamental problem called renewable integration, and it requires a lot of IT instrumentation and AI forecasting, and also ability to participate in short-term energy markets that are operating in 5-minute intervals, 15-minute intervals, and provide demand-supply matching and these sorts of things, right? So it's like an entire IT infrastructure or a cloud-based digital infrastructure that needs to be put in place to manage the flows of power, or to create a new internet of energy, right? So that's what we are working on, applying various kinds of AI technologies. Beyond that, we are working with Microsoft Research on some interesting areas in these virtual battery type areas where I can use cloud itself and make it like a battery. Once I have cloud as a battery, then you can do Bitcoin mining, you can do high performance computing, you can do protein genomics and all these kinds of things, while at the same time serving as a battery for the grid, right? So this can complement lithium-ion batteries or any other forms of batteries and really accelerate the adoption of renewables, right? So because the big pathway to decarbonization, as I told you, of the emissions, 75% is energy. Of the 75% of the energy, a large fraction can be electrified, and then you can sing, right? So since it's a primary pathway, we believe we can make a big impact in this path. Of course, there are many other folks who are working on various aspects. There are people who are doing subsurface modeling of, both for oil and gas, but the same technologies are being used for carbon capture and storage. There are people looking at methane detection and so on. I don't directly work on some of them, but we have colleagues who are working on that. Microsoft itself as an organization has committed to not just being net zero, but carbon negative by 2050. So we are trying to be pioneer in terms of our procurement of renewables. Our data centers are going to become diesel free by 2030. So we have to adopt technologies aggressively, battery technologies, hydrogen technologies, those sorts of things, right? So I work with our colleagues who are in the data center side of things on some of these areas. But I'm glad to report to you that many of these innovations are happening right here in India, right? So as you know, Microsoft is a huge operation out of India. We have Microsoft Research in Bangalore, in Hyderabad, now we have operation in Delhi and so on, right? So we're doing lots of interesting stuff out here. And also India as a market is where we can do innovations in a frugal way and then export it across the world, right? A solar farm is the same in India or when I go to the US or something like that, right? So if I solve a problem around solar in India, then it becomes cut and paste across the world, right? And if you can get it to work in unit economics of India, it becomes much more easier to, we can immediately have a, larger total addressable market, right? So this is why, Kaviraj, also to your earlier point, here you can actually drive innovations out of India and suddenly take it to the world, right? So it's an interesting.
So that wraps up the event. On behalf of the team, I thank Mr. Shivkumar Kalyanaraman for taking out his busy schedule for this talk. I'm sure it was very helpful for everyone, and I also thank everyone for attending this event. Thank you.
Thanks a lot. And just a final word that, hey, look, I'm looking for a lot of Elon Musks to come out of this, right? So a lot of this involves deep engineering, thinking from first principles. You guys have cracked JE, right? This, again, as I said, peanuts. I just need you to have the energy to really go solve the world's problems and a willingness to learn and apply, right? You can break through all the barriers. There's enough entrepreneurial energy, there's a lot of talent, there's money, there is markets, all of these things which were challenging earlier are all available in India, right? And India needs you, and from India, you can solve the world's problems, right? And I really look forward to, great folks coming out of this batch and others, right, from IIT.
Thank you.
Okay, thank you.
Thank you, Shiv. Thanks a lot. Thank you everyone.
Have a nice day. Bye.